This is high enough. Fantastic. Okay, so the beginning of the Cypher demos. Easy one. This was the hint. Your friend was given a secret message. You have to decode it. And this one was pretty easy. We termed that as a Caesar cipher. So I found a website, plugged it in the website, and then I found what the switch was, and it was just 6. Then there's the flag. So that one was pretty good. Easy 2. You're given the hint that this flag is hidden with a XOR encryption. So you have to figure out the key and then figure out the plain text. And what is XOR? It is exclusive OR, and it's just a fun way of doing some encryption. I don't really know any information about it other than what John told me last night. But the key thing here is that it encrypts data the same way that it decrypts data. So if you figure out the key, then you can decrypt the data. So then I was like, I'll just do it out manually because coding stuff is difficult at 3 a.m. And John was like, yeah, no, don't do that. And so I didn't do that. And I used the internet again. And we had this nice XOR calculator. And we plug in the cipher. In the cipher, the first 2 bytes of the hexadecimal was A1. And you know that has to be the first thing in the flag. The first thing in the flag needs to be an R. So use the hexadecimal value of R, which is 52, and use the hexadecimal value of A1 and figure out what the cipher is. Now it's F3. And then we can use some Python stuff. And big shout out to Zach, John, and Dan for their massive help last night at 3 a.m. because I was not functioning well. And we come up with a solution. There it is. And that was easy too.
All right, next up we got Tanshi. Come on down. You're the next contestant on RIT-Sec challenge presentation. There you go. Take it away. Oh, no.
Sorry. All right, so hello. I did Medium 1. So Medium 1, we were given this file with a bunch of 3s and 4s. And in the little box, sorry I didn't get a screenshot of it, but it said that 3s were dots and 4s were the hyphens. So I wrote a Python program to convert the 3s and 4s into Morse code, which was this. And on the right there, I have the Morse code written out. Then I used the same French site that everyone used to decode the XOR thing, and decrypted the Morse code into that jumble of text right there. Then from there, I found this site. It turns out that that text was base 32. For base 64, you didn't really see 4 equal signs at the end, so I tried base 32. Then it gave me this, which is something that I recognize as base 64. So we decoded what the base 32 gave us into base 64, and then we got what looks like hex. So let's try that. Then I use the hex to ASCII converter. Then we get more jumble, more equal signs. We know it could be base 32 or base 64. I tried base 32 first, and then voila, I got the flag.
Thank you. And finally, shield your eyes. We got more light theme from Elliot.
All right, I got 2 minutes before I have to run to class. So, hi, I'm Elliot, UI Office on the challenge board. And once again, we're back to light theme presentations. So, as always, read the prompt, we see that it is password cracking. Fun. So where do password hashes exist in Linux? They exist in shadow files. That's what we're going to be paying attention to. So what do with shadow? We asked John, hey John, what are the passwords?
Probably password.
Well, they aren't. So after 20 minutes of hash cracking, we get our answers, and we have the 4 words we need to assemble. So we assembled a flag, and we win. We get points.
Cool.
All right, and now let's dive into some education slides. This week, we're doing Intro to Web by yours truly. Good luck, it's going to be a doozy. So, we'll jump right into it. What is the web? The web, the World Wide Web, or WWW, is where a bunch of documents are hosted publicly for other people to browse to and see. It is the home of memes. Without it, memes would just be, I don't know, like telegrams or something, I don't know. But not as fun. So all the stuff that we can host for your challenges and stuff like that is thanks to the web. So some key vocab for this, we have HTTP, which is the Hypertext Transfer Protocol. This is how we send and receive data across the web. We have HTML, which is Hypertext Markup Language. That's how all the websites are kind of, what? What is that? Oh, cool, thanks. Glad you're fact-checking me mid-presentation. This is how the websites present their information. And then we have CSS, which is Cascading Style Sheets, which makes all that information looks pretty. I'm garbage at CSS, so all of my websites are white with black text. And JavaScript. So we can run code in our browsers. It's not Java, it's much worse. It's the, quote, language of interactivity. So let's talk about a few basics. HTTP, like I said before, HTTP is how we send and receive data across the internet. It's how our browsers communicate with web servers and vice versa. It uses port 80. It's in the application layer, which is layer 7 of the OSI model. If you don't know what the OSI model is, go to a CSEC class. They talk about it in every one. If you missed that day, don't worry, it'll come up again next semester. Like I said, it uses port 80, which is a TCP port. HTTPS does not use port 80. We'll talk about that later. It uses 443, but that little green lock in your Chrome browser, that's HTTPS secure good. Even though TCP is stateful, HTTP is not. We can get around this in a few different ways. We'll talk about that later. So the way it works is you make some requests. We have several different request types. We call those methods. There's the get and post. Again, more later. We're going to do that soon. And then those return certain status codes. Everyone's heard of the 404 page not found. 400s are bad. Well, we'll get there, buddy. Don't worry. So at the very minimum, our request needs a method, a path, and an HTTP version. I think most common right now is HTTP 1.1, but HTTP 2 is a thing. It's becoming more popular, but it's not quite there yet. Yeah. And then the responses also have headers and bodies most of the time. So getting into some of these methods, like I mentioned, get. So a get request is what, hey, give me information. I want to get information. Anytime you type in a link into your browser, it's a get request. It pulls down the web page and displays it nicely. Another popular one is post. That's how you want to send data. So you can send your password and stuff. That should be done over a post request, not a get request, because security. There's a whole bunch of other ones. I've only ever used get and post for the work that I've done in 380, because that's basically all my experience with web. But yeah, so there's a bunch more. Delete, which I don't know why that exists. I can send a request that says delete and it removes stuff. Wild. There's a bunch of other ones. All right, so I mentioned those status codes before. So they're organized into groups of 100. So the 200, like, yay, cool, your request was valid, here's your information. We have your 300, which it's going to redirect you. So you say you go to a site that's no longer there, but they set up that 300 redirect. You'll get that 300 status code with a new page to go to, and your browser will like flip through those things. If you ever clicked on an ad and it cycles through like 4 different web pages, those are redirects. We have our 400 errors, 404, page not found, or 418 if it's a teapot. Look up that RSC if you're confused. It's a solid meme. So those are what happens when you messed up, right? If you sent data that it wasn't expected to receive and it doesn't know how to handle it, you can get a 400 error. If the page isn't there, you type in the wrong one. 400 errors are usually your fault. But 500 errors, that's the server's fault, or your fault if you messed up your 380 homework. So if something's configured wrong internally, you'll get that, I think it's, 503 internal server error, and there's just like, yeah, it doesn't work, sorry. Yeah. All right, so into headers. A header provides metadata for the request information. So they have that key value syntax. It's almost like a dictionary. So key, colon, space is your value, is how the headers are formatted. It tells us things about the client and server, what kind of content they're expecting. Content type is a common header. Content length, how large the body is going to be. If you're sending a post request, you also need to send a content length with how many bytes you're sending in the post request. It'll also, when you return data from a GET request, it'll also say how long the body is, so your browser knows what to expect and not to expect anymore, kind of thing. Who's making the request? Your user agent, right? So the user agent for Chrome will look different than IE, which will look different than Edge. Excuse me. There's a whole bunch of headers. Some of them are standard. There's a cool link here. When I post the slides later, feel free to browse to it and enjoy reading this Wikipedia page. So cookies. If you were here, I think it was 2 weeks ago, Haim had a long talk about cookies. It was pretty good. I believe it's been posted to YouTube now, right, John? All the videos from the previous are posted? Oh, fuck. All right. Eventually, John will post them to YouTube, and you'll be able to watch it. Oh, that's right. I forgot. Sorry. You can't watch it. Ooh, that's awkward. So cookies they pass information back and forth between the client and server, and it kind of maintains a certain state, right? So if you log in once, if you go to a new page on the website, you don't have to log in for every single different page you go to. So I log into Facebook and I go to my friend's page. I don't have to re-log in for every different friend's page I want to see. They're stored on the client, but they're set by the server. They usually have tamper protections. If they don't, you can change them and potentially log in as someone else with a different cookie. If they're weak, they can be brute forced. So do all that stuff server side. Also, they'll set the cookie flag, but all the information will be actually stored on the server, so you can't manipulate it, which is pretty good. And then Flask does this cool thing where it's signed by the server and signed by the server to detect tampering. So you can't change them. If it changes, it yells at you. I'm thirsty. This wasn't from last year, and I could not remove it. It was too good. So the body. So this is where the main content is. When you send a GET request, the server will respond with the body that is the HTML for the page and all the CSS and all that information. The body of the post request, like I mentioned before, this is the data you want to send to a server, like your username and password or whatever other kind of data you want to send. And then some methods have no body, like head. So HTTP. Your browser isn't the only thing that can use to send requests. You can use various command line tools. Python and Go have some pretty cool request libraries, so you can do it programmatically. You can manually netcat and send each line of a header to get stuff. That's awful, but you can do it. Curl is pretty hot. You can send different kinds of methods, pull data, send data, all that cool stuff. And then at 380, you get to make your own sockets library. It sucks, but it's really useful for some of the homeworks. So you get to basically do the netcat thing where you manually send all this stuff, but you use Python and raw sockets. Not raw sockets, but the Python sockets. So HTML, CSS. HTML, like I said before, is like how all the data is sent to your browser and rendered, and the CSS makes it look pretty. So HTML has tags, your head tags, your body tags, your title tags. There's a couple of them defined as what you need to be for each page, like the doc type and stuff like that. I forget the website for that. It's like W3 Schools has a thing that'll check your HTML to make sure it has all the valid tags and stuff. There's attributes, you can refer to them. So like the div ID, my div, and then you can refer to that later. Like in our CSS, we can make sure that the background of that div is red. JavaScript. So JavaScript is a scripting language that you can run in your browser. If it's not secured well, you can do remote code execution through it. So it's pretty scary, but it's also pretty convenient if you do it right. And they put it everywhere. It's designed to interact with the web content, like making the ads follow your cursor. So when you want to click X, it moves over like enough pixels so you don't click the X and you get redirected. It's fun. You can also use it to steal cookies and sessions and stuff. So if a site has malicious JavaScript on it that someone has taken over, it can steal your cookie for your authentication, and then they are you, essentially. So be careful. The developer console. I'm sure everyone here, or most people, have clicked Inspect Element before, and there's like a ton of stuff there that you haven't seen or don't really know what it is. It's really cool. You can see all of the HTML and stuff from the page. There's also, hang on, can we do it from here? Oh, it didn't open on that one, sad. I was going to try and open it. There's a cool thing for network. It'll like trace through all of the requests that you've sent and what gets responded from the server. You can go through and edit them sometimes, depending on the browser. The Chrome one is the best by far, but the other ones still have some cool stuff in them. There's a console, so you can run your own JavaScript. So like console.log, document.cookie, you can print any cookies that's been saved on that page. Is pretty easy. So if you're bored, spend some time in there. You can change the content of the websites. Fun little story time. My sister is in middle school, and she's like, yeah, we hack people. I was like, what do you mean you hack people? She's like, yeah, you just inspect element and then change the words. Their website's different. I was like, oh, you sweet summer child. But it's cool that she's like getting into that stuff. So spend some time, have some fun, mess with your friends, all that good stuff. So like I said before, wow. So I also put in here, watch Haim's talk, because I forgot it wasn't streamed. Sorry, if you saw Haim's talk, then it was pretty good. So robots.txt, you can put a robots.txt file on your site, and so things like crawlers in Google like won't index it. It's usually followed by the big companies that will, but if someone with malicious intention is trying to grab your stuff, it might not always work. All right, HTTPS. So last week we talked about crypto. So what HTTPS does, it takes HTTP and wraps it in encryption. It uses keys and certificates and stuff from different certificate authorities to ensure your data. Again, that's that little green lock in your browser. So you're a webmaster now. I'm just kidding. I'm far from it, and then most of you probably aren't either. Anyone have any questions before we move on? Cool. So let's talk about some exploits and mitigations for this stuff. JavaScript. Since JavaScript is run in your browser, you can control and modify it, which can be pretty scary. For things that authenticate on the client side instead of the server side, you can just say, yes, I'm who I believe I am, or who I say I am, and the server just believes it. You shouldn't do this. Authenticate on the server side, make the server do the work, and validate. Cross-site scripting, if you can put your own JavaScript in a web page, so when someone else goes to it, it executes, it can lead to bad things. So there's two different kinds, stored versus reflected. Stored, if you were to put it there, it stays there, so anyone that goes to it, it will run, or reflected, it just runs once on your side. What else? Yeah, so like I mentioned before, we can use this for cookie stealing. You can throw the JavaScript in there, it'll grab those cookies, and then send them to you as a malicious actor, and then you have people's authentication tokens. So CSRF, or cross-site request forgery. It's where a user is tricked into making requests to a site that they already authenticated from a separate site. Again, with some of that bad JavaScript stuff, I can log into a certain site where I can potentially change my password. Another site has a tag that that uses the other site's information. It's kind of hard to explain. I'm bad at this. I'm sorry. To change your password, and then the next time you visit it, it'll have changed it to whatever the malicious intention on the one site had done, and then when you go back to the other one, it'll have been changed to whatever the hacker wanted, and then you'll be locked out. Some mitigations for this. Luckily, this takes like a lot of things to line up to make it work. So they can be fixed with some simple things like CSRF tokens, which say so every like session that you log into, you have to have that token stored after you authenticate. So if someone was going to do CSRF from another website, they wouldn't have that token and it would be stopped. All right, server-side request forgery. This occurs when a user has full or partial control over requests being made by a server, so they can kind of modify their request to make it do what they want. So, sorry, I don't remember this slide. Server status. Shit, I did not say this slide, I'm sorry. Wow, I feel bad now. Web is hard, but that's why we're here, to make it easier. So you can whitelist sites for this. So you can say only allow this site to make requests. So if you are on a web server and you've broken that, like don't let it send requests to your AD controller, because that would be bad. You can also do sanitation. This is a pretty common theme across all of these things. If you just make sure that no one's sending bad information and you only allow certain things that are as intended functionality and block everything else, it'll solve a lot of these problems. Also, if anyone's ever gone like file : / in their browser and they can like move through their file system with that and open files that way, if you disable those, it can't be used. All right, SQL injection. So a lot of websites have SQL database backends where they store like your username and password information. They'll hash your password and throw it in a database. If it is configured poorly or doesn't have any security features enabled, you can basically dump all of that and use that to move your way through the system. So if anyone's heard of that TICOR 1 = 1 and it returns like all the information, you can do that. Again, a good way to fix this, sanitize your inputs. If you don't allow them to send TICOR 1 = 1 or any variation of that, they can enumerate your database. There's also a cool tool for this called SQL dump, SQL map, one of those, I forget. It'll basically enumerate the database for you and give you all the stuff. It's pretty cool. Another thing called prepared statements. It'll only have a list of certain things that you're allowed to send. So a username and a password and nothing else. It'll kind of have those listed out. There's also a database abstraction layer. I've tried to understand this, I really don't. It's kind of like an API for the database, so there's like a middleman for it, is what I understand, which kind of makes sense. All right, local file inclusion. So usually, if it's configured right, you're only allowed to see the file that is the web page that the server wants you. But if it's configured wrong, you can put like a lot of .. slashes, like a bunch, to get you back to the root directory, and then look at, say, etsy password, for example. So if this isn't configured right and you allow the website user to get 2 files across your whole system, it can lead to bad things like password dumps and all that. So only limit it to the files that you want it to see, like the index.html and any other like sub pages that you want. Again, sanitize your inputs. This is, again, a common theme. If you don't allow it to put things like .. / that you don't want it to see, it can't put them. Easy mode. Don't let users specify arbitrary files, so I can't go into the web browser and like type in the file path. I actually have to click a specific link in the page. Command injection. So this is kind of similar to local file inclusion, but if it takes any arbitrary input and execute commands on the back end, that's pretty bad. So say you want to look at a file, open a file via the web server, and in the back end it runs cat the file name. You could then just put a semicolon after that and also run any other command that you want, like rmrf. This is bad. So what you should do instead is, instead of having it pass raw system commands, you should use some sort of abstraction layer to do it for you. So for example, in Python, instead of os.system cat file name, you can use file open with opens. And there's a whole bunch of ways you can do it. I just use f.open. Oh, also, another important part, don't run your web server as root. It usually yells at you if you've ever tried to change the user that Apache runs as. It's like, you really shouldn't do this, bud. This is a bad idea. And you have to click through like 4 prompts to say that you want to do it. Yeah, so usually there's a user that comes with it, like www.data, that has very limited permissions and usually can only see the var www directory and nothing else. So this can help stop that. Also, if they don't have permissions to run any commands, that also helps. All right, some tips and tricks. A lot of the problems that we do, like I mentioned before, can be mitigated by input sanitization. This is really important. So if you can implement this, this is pretty cool. Recon is important. If you're trying to exploit web servers, figure out some information on it. What is it running? What's the backend? How can you exploit it? Are there any known exploits for it? Figure out what version it is. Check out exploit.db, stuff like that. Programming is your friend. Once you know what a vulnerability is, try and automate that so it can be repeated. When you're doing this ethically, because you shouldn't do bad things, you can then show that in a report or something like that and say, this is the problem, here's the code that I wrote that exploits it, and here's how to fix it, and you can show that it happens every time. So we got some cool resources. Again, I'll post these soon, TM. There's a bunch of cool links, the OS top 10. I think at some point Shannon wants to give a presentation on that. I don't know that it's actually today. Is it today? Woo! So that's pretty cool. These are the ones from 2017 because they haven't made any new ones, but there's also, I believe, the general one, which is pretty cool. The Web Application Hacker's Handbook is a pretty neat book if you want to get into some of this web stuff. This is generally some pretty important content. The web is everywhere. And my week 1 slides, I kind of brushed on it recently. There was like a refrigerator running Edge. If you can exploit stuff that is literally everywhere, it's pretty bad. So web application security is pretty important. There's that status code link from before. SQL map, see, I was right. That's that thing that'll enumerate the database. So all these links are some helpful resources for you, and I'll post them soon, TM. All right, actually, anyone got any questions? Sorry, I know I kind of went through that fast. Cool. It's demo time. Come on up, Joey.
So for the demos, everything is posted in demo help. In this week, it's going to be a black box. So you just download the VM, you run it, and you just scan your subnet, and find the address. And I already told what kind of ports are there in the challenges, so you can just go there, visit it with your browser, and you can start doing the challenges. And please beware, testing any kind of web-related stuff that is not yours is against the law. And I say this especially for web because it's so easy to like test web. You can just literally go any website and you can do any type of techniques on there. So please do not do it. Only do it against the challenge VMs unless you want to go to jail.
Be good, not bad.